Welcome back, students. Today we will study about the modern periodic table. In last class we read that Dmitry Mendeleev has given a Mendeleev periodic table and his table was rejected because he could not explain many of the properties. So later on in 1913 H.G.J. Moseley he has proposed one table which is named as modern periodic table. Until date, we are following his table. In modern periodic law, he stated that properties of elements are periodic function of their atomic numbers. But Mendeleev told that the properties of elements are periodic function of their atomic mass. But it could not explain many of the properties, that is why it was rejected. What is atomic number? Atomic number is number of protons present in an atom. What is atomic number? Atomic number is number of protons present in an atom, which is also equal to the number of electrons present in an atom. In class 9, we read that in an isolated neutral gaseous atom, the number of protons is equals to the number of electrons. Protons are positively charged and electrons are negatively charged. So, an atom is electrically neutral. An atom is electrically neutral. So, this 23 represents its mass number. This 23 represents its mass number. What do you mean by mass number? Mass number is equal to the sum of proton plus neutron. Sum of proton plus neutron. So, we can say what is neutron? Neutron is equals to mass number minus protons. Neutron is equals to mass number minus protons. So, how many in this element, in this atom sodium, how many protons are there? 11. How many electrons are there? 11. How many neutrons are there? 23 minus 11, that is 12. And what is its electronic configuration? 2, 8, 1. In the first cell, 2 electrons. In the second cell, 8 electrons. In the third cell, 1 electron. So, this atom is electrically neutral. Now, through modern periodic table, all the anomalies of Mendeleev classification disappeared. Whatever the Mendeleev, the anomalies which were present in the Mendeleev table, it was disappeared in modern periodic table. First, the position of isotopes. What is isotope? I told you in the last video. The isotope means the atom of same element having the same atomic number but different mass number. The atoms of same element having same atomic number but different mass number. So, the isotopes were placed properly. The noble gases were placed and the cobalt and nickel. The cobalt atomic number is 27 and nickel atomic number is 28. So, as nickel is greater than cobalt, so it is placed later on. So, it is placed after cobalt. So, this anomaly which was present in Mendeleev classification, it is explained. And one more, like lithium and silver. Lithium and silver, they both share the different properties. They both share the different properties and but were placed in the same group in Mendeleev periodic table, which was resolved in modern periodic table. Now they are placed apart. Okay, and lanthanide series and actinide series also we can see in the modern periodic table. So, explanation of the anomalies by modern periodic table. Explanation for the position of isotope. Same atomic number put at one place in the same group. Cobalt with atomic number 27 came first and nickel should come later. So, it was solved. Unlike atomic masses, atomic number is always a whole number. We have seen in the Mendeleev periodic table that atomic mass we have seen in the decimals, but unlike atomic mass, atomic number will be always in a whole number and there is no element between hydrogen and helium. And position of noble gases is also placed in properly in the periodic table. Now, what do you mean by atomic number? Atomic number, I already told you that the number of protons present in the nucleus of an atom. Okay, it is denoted by Z. It is denoted by Z. and mass number is denoted by A. Mass number is denoted by A. So protons and protons and neutrons collectively, what it is known as? Nucleons. What it is known as? Nucleons. We have seen that there are 18 vertical columns in modern periodic table. How many groups are there? There are 18 groups. How many periods are there? There are 7 periods in the modern periodic table. Now, let us take an example. Elements with same number of valence electrons are placed in the same group. The elements, the lithium atomic number is 3, sodium atomic number is 11, potassium atomic number is 19. So, what will be its electronic configuration? Lithium atomic number 3. So, its electronic configuration is 2 and 1. Sodium 281, potassium 2881. Now, let's see the metals, the elements which are placed in the first group, we call it as an alkali metals. We call it as an alkali metal. You see that lithium has an atomic number 3, sodium 11, potassium 19. So, lithium 3 electronic configuration 2 and 1. Sodium 11, so 281. Potassium 19, so 2881. What are you seeing common in this? That all the cells, all the last cell contains 1 electrons. All the valence shells contains 1 electrons. Understood? See, all the valence cell. What do you mean by valence cell? Valence cell means an outermost cell. Means outermost cell or an orbit. All the valence cell contains 1 electron. So, they are placed in the same group. So, they are placed in the same group. It also denotes that any element, in an element, the electrons present in the outermost cell of an element denotes its denotes its group. In an element, the valence electrons represents its group. In an element, the valence electron represents its group. And we can, as we will see that as we go down the group, the number of shells are increasing. As we are going down the group, the number of shells are increasing. In first, see, it is 2 period, 2 shells. It is 3 cells. This is 4, 5 and so on. So, outermost or valence cell in all the 3 contains 1 electrons. These elements have been placed in the same group. So, how can we identify that the element belongs to which group? By seeing the number of electron in the outermost cell. By seeing the electrons in the outermost cell. If there are 2 electrons in the outermost cell, it belongs to group 2. If it is 4, it belongs to group 4. If it has 5, it belongs to group 5 and so on. And we are seeing that the number of cells increases as we go down the group. Clear? Now, elements with same number of occupied cells are placed in same periods. Now, how will you identify that the element belongs to which period? By seeing that how many cells are there, how many cells are occupied by this element. By seeing the number of cells occupied by the element denotes its period. In this case, we can see that they all contain 2 shells. Lithium also contains 2 shells, 2 and 1. Beryllium also 2, boron 2, 3, carbon 2, 4, nitrogen 2, 5. They all contain 2 shells. So, they all belong to group 2. So, they all belong to period 2. They all belong to period 2. Now, you see, in lithium there are 2 periods. One cell, first cell, which contains 2 electrons. Second cell contains 1 electron. So, there are 2 shells. So, it belongs to group 2. But sodium, it contains 3 shells. 1, 2 and 3. In the first cell, it contains 2 electrons. In the second cell, it contains 8 electrons. In the third cell, it contains 1 electron. So, it belongs to third period. Now, potassium, see, there are 2 electrons, 4 shells are there, 1, 2, 3, 4. In the first cell 2, in the second cell 8, in the third cell 8 and in the fourth cell 1. So, it belongs to fourth period and group 1. Now, let me take an arbitrary one example. Silicon. Silicon, see how many cells are there? 1, 2, 3. What is its atomic number? 14. So what will be its electronic configuration? 284. 28284. So there are 3 shells. So it belongs to third period. And which group? As there are 4 electrons in the outermost cell, so it belongs to fourth group. So third period and fourth group. Third period and fourth group. Clear? Let us take one more example. Fluorine. Fluorine has an atomic number 9. Okay. So 2 and 7. 2 and 7. So in there it contains 2 shells. It belongs to group 2. And how many valence electrons? 1, 2, 3, 4, 5, 6, 7. So it belongs to group 7 and period 2. Whereas in neon, its atomic number is 10. Okay. So and neon, it has atomic number 10 and 2 and 8. So it contains stable electronic configuration. So it belongs to group 8 and period 2. So now maximum number of electrons that can be filled in a shell is given by 2n square, by this formula 2n square, where n denotes its shell number. N, so 2 into 1 square 2, 2 into 2 square 8. So this is the maximum number of electrons which a shell can accommodate. The first cell cannot accommodate more than 2 electrons, and the second cell and so on, it cannot accommodate more than 8 electrons. Clear? Now position of an element in the periodic table tells us its chemical reactivity. Then we can find out that how reactive it is or how less reactive it is. Now what is valence or valency? Valency is the combining capacity. We read in class 9. Valency is the combining capacity which an atom or element either donate or accept to obtain a stable state configuration. To obtain a stable state configuration. Okay. Suppose they have 2 electrons in their outermost cell. To obtain a stable octet configuration, they will donate 2 electrons. So what will be its valency? Be2 plus. Magnesium Mg2 plus. Calcium Ca2 plus. And they all have 2 electrons in their outermost shell. So they belong to which group? Group 2. And they are referred as a alkaline earth metals. This group is referred as a alkaline earth metals. Clear? Now in next class we will study in more detail by taking more example. Till then, please watch this video, and if you have any doubt, please let me know so that I can solve your problem. Stay at home, stay safe. Thank you.